Hey everyone, welcome back to the channel. In today's video, we are diving deep into automating the extraction and custom processing of Sentinel-2 imagery using Python. If you are into remote sensing, satellite data analysis, or GIS, so this one's for you. Before explaining the code, first I will run the code and show you how it's work. So on the right side, as you can see, the zip folder which is downloaded from the Copernicus website. These are the Sentinel-2 data. Now run the code. Now it will ask for the input and output directory. So here is the Sentinel-2. Here it will find the zip folders, and now where you want to save the output. So the output folder is 01. Now here you can see the zip extraction is automated. Okay, now we check our output folder. So the code created a custom band stacks folder, and inside the folder, now you can see it will take some time. Now here you can see one of the custom band stack is processed. Now the code is working on the second one. Okay, now uh, import the image on QGIS raster raster dataset. Now where is the our processed image? 01 custom band stack 1 and 2. Open add. Okay, now here you can see. Okay, let me quickly explain what we are working with here. Sentinel-2 is a European space agency, as I told you, which is designed for Earth observation, and it captures multispectral images with the 13 bands. I will show you the bands, granules, and image data. So these are the 13 bands. So these images are stored in zip archive, as you can see, and need to be processed into usable data stacks. So with Python, we can automate the entire workflow, saving hours of manual work. Now let's take a look at the Python code that automates the zip Sentinel-2 data files. These files usually comes as a .zip archive containing the image data in a folder structure. So we begin using the extraction file. When we run the code, first it will ask the input directory where the zip file is placed, and the second the output folder where you want to processed file saved. So first check for the new zip file for extraction. It will check for the zip files if exist. Then it will extract the zip file. The folder name are based on the zip file name, so it keeps everything organized. Additionally, we make sure the extracted files are clean and don't have any unnecessary nested folders by moving content into the correct structure. So we deal with the folders inside the Sentinel-2 data. The key here is to find the correct bands. These are the layers that make up the satellite images. I already show you the 13 bands. So our bands of interest is 2, 3, 4, 8 and 12. These four bands are have the same resolution, but the B12 is the different resolution. B12 is the 60 meter, and the rest of the four is 10 meter. So these bands are important for analysis like vegetation indices or water quality monitoring. So for this we use our library Rasterio to read these bands as individual dot jpg2 files, ensuring they exist before proceeding with any processing. Now what's our magic part, which is band stacking. So we take these individual bands and stack them into a single multi-band image. So this is important because many analysis requires multi-band data in one file. Now here you can see first it will check all the bands are found. If found, then proceed with the code. After that, after finding the bands, then the code check the resolutions of the five bands. So B12 is the different resolution, which is the 60 meters resolution. So then it resampling the B12 band and all the five bands with the same size. So we use the Rasterio resampling features to ensure all bands match in sizes. So finally, we write the stack bands to an output file. This is where the code saves everything into an .img format using the Rasterio library, and also attach the metadata with the .img file for aligning on its place on the GIS software. So this final output, as you can see, this is our final output. Five bands combined into a single file, ready for further analysis in any GIS software. As with any automation, we have added error handling as well. If any band is missing or the bands have different shapes that can't be resampled, so we skip that data folder to avoid errors later in the process. So this ensures that the script runs smoothly without manual interventions, which is especially useful when dealing with large data sets. So in a nutshell, this Python script automates the process of extracting Sentinel-2 data from zip archive, organizing the bands, creating custom band stacks, and resampling when necessary. If you are working with remote sensing data, so this is the real-time saver. So that's it for today's video. I hope you find it helpful. If you did be, that's it for today's video. I hope you find it helpful. If you did, be sure to hit that like button and subscribe for more content on remote sensing and GIS automation. So drop any questions you have in the comment below and I will be happy to help.